Examples of balanced and unbalanced forces. Let's see the first example. It is about tug of war. This is the game. Each group will exert force in order to pull the rope to their side. If the rope doesn't move, then the net force done by Team 1 is equal to the net force done by Team 2. But it is in different directions. So we draw the forces like this. The first team is pulling to the left and the second team is pulling to the right. And the length of the arrows is equal because the two teams are exerting the same force. In this case, the forces are called balanced forces and the rope is stationary. However, if one of the teams exerted a greater force, then the rope will move towards the direction of the greater force. For example, if Team 2 exerts a net force on the rope more than the net force exerted by Team 1 on the rope, so as you can see, the arrow for Team 2 is longer than Team 1, then the rope will move to the side of Team 2. So these are unbalanced forces. That means the rope moves to the direction of the greater force. The same applies if Team 1 exerts a net force on the rope more than the net force exerted by Team 2 on the rope. As you can see, the arrow for Team 1 is longer than Team 2, then the rope will move to the side of Team 1. These are also unbalanced forces. That means the rope moves to the direction of the greater force. We can conclude the following. The unbalanced forces acting on the rope caused it to accelerate. The rope was stationary and its speed was 0. However, then the rope accelerated towards the bigger force. So the unbalanced forces causes acceleration. Now let's see example 2. It is about a car. The car is designed to have an enormous acceleration from rest. We need to define the forces that are affecting the car as it moves. The first force is the weight, which pulls it downwards, also known as the gravitational force. Since the car is moving on a surface, then that means we have a normal reaction force, which is to the opposite side of the weight. The weight is a vertical downward force, while the normal reaction force is an upward vertical force. Since the car is not moving downward or upward, that shows that the weight and the normal reaction forces are balanced forces. That is why the arrow for each force is equal in length. So the normal reaction force and the weight are balanced forces. That means the vertical net force is equal to normal reaction force minus weight, which is equal to 0. We put the minus because they have opposite directions. The direction upward is positive and the direction downward is negative. Now, let's look at the third force, which is the thrust force. It is the force pushing forward which is caused by the motor of the car. Also, we have the friction force. This means that there is a friction between the car and the ground. It is on the opposite side of the motion. Also, we have the drag force, which is the friction with the air, so it is an air resistance force. It is similar to the friction force since it is on the opposite side of the motion. Remember, we said that the normal reaction force and the weight are balanced forces and their net force is 0. So we will focus on the thrust, drag, and friction forces. In order for the car to move and to be fast, the thrust must be higher than the net force between drag and friction forces. In this case, these three are unbalanced forces. So, the thrust force and the drag and the friction force are unbalanced forces. That means the car will accelerate. However, If the thrust forces and the friction forces are balanced forces, then the car moves at a steady speed. That means no acceleration.